right. Y'all doing all right? So, you know how I don't want y'all using your phones during class? I'm just giving you all a heads up. I'm expecting an important phone call. So if I do get that call, I'm going to just step outside, just so you know. Rodrigo, just come up and grab these exams. I do not believe I put your grades on here, but your grades are online, right? Okay. Elena? Macy? Wait, Macy? Yeah, Macy? Macy? Elena? What's that? She's not here. Okay. Kayleen? Kristen? Oops. Alexander? Vince? I think it says Heidi. Heidi? Yes. Devin? Rebecca? That's you? Yep. Okay. Tiani? Yeah, that's what I was going to say. She's right there. Itzel? Itzel. Kiana? Caroline? What happened?
Oh, I just sprained it.
Oh, you sprained it. My stepdaughter totaled her car on Thursday and broke her foot. Damien? Damien? No. I think she's getting x-rays right now. Zeke? Zeke? Frank? Joshua? Andrea? Let's see, Evan? Stephanie? Cruz? Okay. Christine Gonzalez? Christine Gonzalez? No, Christian, that's you. There's a Christine. Victoria? Okay, all right. So while you're kind of looking at those, I will tell you a little bit about the grades. So let's see here. I took a picture so I could do a quick summary here. So the highest score on the test was 100. We had 3 of those. The class average, which we usually write X bar, was 74.52%. And the standard deviation, which is basically means how close y'all were together. I told you all a little bit about this before, last test. You may or may not remember that. That was this exam, okay, exam 2. Exam 1, our class average was a 72.58, and our standard deviation was an 18.54, so about 18.6 or so. So you can see that we had about the same average, went up a little bit, and we had about the same standard deviation. Now in terms of A's, B's, C's, D's, and F's, on this exam, we had 7 A's, 3 B's, 8 C's, 3 D's, 4 F's. On exam 1, we only had 4 A's, we had 5 B's, 7 C's, 6 D's, and 4 F's. So that's where we are, okay? So I would say that, you know, if you've been in this category for 2 exams now, I would just come sit down with me in my office during my office hours. Just look and see if you can fit that into your schedule. We can sit down and talk about, you know, where you're having troubles, maybe a little bit about, you know, how you're studying, and maybe we can find a strategy that will help you. Because if we continue doing the same thing, then, you know, we shouldn't expect anything different to happen. There's a famous quote by Albert Einstein that's his definition of insanity. Have you all ever heard of that? His definition of insanity is doing the same thing over and over and expecting a different result each time. So you know, if you're here, it's not over. We still have 3 exams, right? We have 3. Yeah, there's a total of 5 exams in this class. 2 more that we're going to do during the semester, and then the final. So there's time to recover your grade if you're down here, but you've got to do something like immediately about that. So, and on the other hand, if you're doing well, then you know, continue what you're doing, but don't take your foot off the gas, because there's 3 exams still, and you could turn your grade the other way. So, yeah, I mean, I'm happy with these results in terms of class average. I think we had 1 or 2 fewer students take the test, if I'm not mistaken. So we may have lost 1 or 2 students in the class, which happens. Okay, any questions on the test? Let me tell you how I calculated it. How many problems did we have? 10? No. Oh, we had 10, so they're each worth 10. So pretty easy to figure out. Any questions over the tests? If you got something wrong and I didn't tell you what you got wrong, it's because I want you to try and figure out what you got wrong. Usually I'll circle something just to kind of give you an idea of what's missing, or so work through that. You may see these again, right? These problems might appear again on the final. Normally the final exam, I just go and kind of go through each exam and pick out like my favorite problems or the problems I want to put on the final. So you might see this again, so you want to make sure you understand it. No questions? Okay, so everybody here today is going to get a quiz grade of 100 for being here because it's a holiday, and if I were a student, I would probably have taken the day off. So I'm going to reward you for being here. So what we're going to do is, if somebody can do a sacrificial piece of paper, we're going to pass it around as a sign-in sheet. You got it? We'll start it over here. So just, if you could, put on there, on the top of it, put today's date, so it's October, put 13-14. Okay, and then put today's date, October 14th. And then just print your name, okay? Print your name so I can read it. All right, now, today what we're going to do is more factoring. And with my stepdaughter having that car accident, I've been like kind of all out of sorts because it really threw me off the last week at the end of the week. So I forgot my backpack at home today that has my computer in it and a bunch of other stuff, but I still have the notes we can go off of here. So I'm just going to be putting problems up here, and yeah, okay. So factoring, how did that go? Any questions over any factoring? Anyone try the homework yet? Anyone have any issues with any of them? We had strategies, right? We had a factoring strategy that we established last time. Let's put that on the board so we can refer to it. What was the first step for factoring? GCF, right? I thought about giving a quiz right to start class today, but I was like, you know what? Let's not do that. Okay, so GCF, right? 2? Count the terms. So we count how many terms there are. And we had 3 basic cases that we could get here, right? With the number of terms. Did I list it out? A, B, did I do A, B, C? Yeah, A, B, C. Okay, so A was if we have what? 4 terms. And what do we do if we have 4 terms? Group. Okay, if we have 3 terms, it's either AC method or guess and check, right? I'm just going to put AC method. And then C was 2 terms, and I said for that it would be difference of squares, difference of cubes, or sum of cubes, but I said we're only going to do difference of squares. And that we did not do last class, right? Difference squares. So that's what we're going to start with today. We're going to do problems that involve 2 terms. And then after that, we will have pretty much a general factoring strategy for all the problems that you'll see in this class, all right? So we'll start off with this idea of 2 terms. I'm gonna start by working a problem backwards. So it's already gonna be factored. We're gonna multiply it out, and then we're gonna try and go the other direction. So let's take a look at, as an example here, what if you had like x plus 2 in parentheses times x minus 2, and I asked you to multiply this? Okay, so notice that those two factors, right, these two things in parentheses are very similar to one another, right? One of them is x plus 2, the other one is x minus 2. So the only difference between the two is the positive and the negative, right? So if we multiply this out, that means we have to FOIL it, right? Then our first multiplication would give us what? X squared. Okay, now pay close attention to the next multiplication here. This times this would give you what? Minus 2x. And then this one right here will be plus 2x, right? And those are going to be the same thing, but they're just different signs, right? So the key for this is for us to understand that this would always happen, okay? This would always happen if this was a plus and this was a minus, and these two numbers were the same, then this middle thing would always be that, wouldn't it? It would always be opposite. Okay, we still have one more multiplication, here to here. What would that give you? Minus 2 squared, so minus 4. Okay, so these two in the middle cancel. And so what we get here is x squared minus 4. All right? So this is not factored, right? If we went from here to here, that would be factored. And that's what we want to do. So the way we're going to do this is we're going to now, after we've kind of seen that first example, we're going to try and come up with like a general formula. So what if we had x plus a number, let's just say plus a, and then we had x minus a. And what if we did the same thing? All right, so if we multiply through here, we would get x squared. What would our next one be? Positive or negative? Negative. Oops, I put plus. Minus, then what? A times x or x times a, however you want to write it. I'm going to write it a times x, ax. Then the middle one would be plus ax. And again, you see they're opposite of one another, so they're going to cancel. And then the last thing would be minus, right? And then a times a, which is a squared. And then these two are gone. So what is my final result here? X squared minus a squared. So again, this is not factored. This is what it would be factored. So if you ever see two things that are squared, right? This x is squared and this a is squared. If you ever see two things that are squared and subtraction between them, then what we have is what we call a difference of squares. Difference meaning subtraction, right? You have a difference of two things that are being squared. So whenever we see this difference of squares, we don't need to go through any process. We just need to memorize or have written down the formula for it. So from here on out, anytime we see this, we just need to know that x squared minus a squared will always turn into x plus a times x minus, that's not x minus a. And that is it. That's our difference of squares formula. So I told you we're going to skip difference of cubes and sum of cubes, right? We're going to skip that, but I just want to show you real quick, don't write this down, that if you had a difference of cubes, okay, two things that were being subtracted and this one was cubed and this one was cubed, there's a formula for that one also. And let me write it down. Again, you don't need this, but you'll see why we stay away from it. Okay, so that's the formula for it. It's more complicated, isn't it? This is a much more complicated formula than this one. And then the one that you can do it, if there's a plus between two cubes, there's a formula also, all right? So we're just avoiding this completely. Now, let's do an example, all right? So we'll start very basic again. All right. So the instructions here are to factor. So we look at it, first thing we do, GCF, okay? Is there a greatest common factor? No. right? There's no number that comes out. There's no letter in both of them. So there's no GCF. So then we go count the terms. 1, 2. We have 2 terms. If we ever have 2 terms, there's only one thing it can be, right? It's got to be a difference of squares. If it's not a difference of squares, we're not going to be able to factor it. But in this problem, we have to look at it. Do we see a difference of squares? Do you see something squared minus something squared? So 81 is a perfect square, right? It's 9 times 9. So you could write this like that. And then that looks exactly like this formula, doesn't it? So for us here, x is just x. And for us, a is really, what's a for us? A is the thing being squared. So what's the thing being squared over there? 9, right? 9 is the thing being squared. So what are we going to write? Are we going to write x plus 81, x minus 81, or are we going to do x plus 9, x minus 9? Plus and minus 9, right? So x plus 9, x minus 9. And just for the sake of being somewhat thorough, this is also correct. It does not matter which way you arrange those because multiplication commutes. All right, they're both correct answers. And that's it, we're done. We have factored it, right? We have turned it into 2 things being multiplied. Okay, moving along. How about this? Factor this. Negative 3 x to the 4th plus, let's see, 75x squared. Okay, so this is about as easy as a problem can ever get. You have something squared minus 81, which is a perfect square, right? As long as you know that 81 is a perfect square, you're in business, right? What are the perfect squares, by the way? Like 1 squared is 1, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 7 squared, right? How far can you go? This is a rhetorical question. What's next? 64, that's 8 squared. 81, that's 9 squared. 10 squared is 100. 11 squared. 121, 12 squared. 144, 13 squared. 169, 14 squared. 196, 15 squared. 225. Okay. You stop there? Okay, good. That's good. So I have a 10-year-old daughter, and I'm not like pressing math on her. Trust me, I'm not like trying to turn her into a math person. But since she's been very young, we've been doing this thing at night when I tuck her in, where I'll read her a story or something. But we do this thing where she lays down on her stomach and I draw on her back with my finger, right? So what I used to do in the very beginning was draw letters, right? So I would try and draw a letter. She'd close her eyes and she'd try and guess what letter it was, right? So we started that when she was learning her alphabet. So a couple of years ago, we started doing math, right? So I'd do numbers, and then it started to become like 3 plus 4, stuff like that. So right now, she's right here. I can do like 3. I'll tell her like, okay, this is 3. I'll write 3 squared, and she'll have to like, first she'll have to figure out if she can feel what it is, right? It's like she has to feel like that's a 3 and then that's squared. So we did this last night, actually, and she stops here. This is where she stops also. I don't know why I'm telling you that. So, okay, so this list right here, you should be comfortable up to about 144. Like you should know the perfect squares for the first 12 numbers. After that, it depends on you. But I'm on a test, I'm not going to give you some weird square that you haven't seen, like 23 squared. Okay, I'm not going to give you that. But I think anything from 144 down is fair, all right? So this is the easiest case. You see something squared minus a perfect square that you recognize. Easy. Here, it's a little bit different. So what do we got? First step? GCF. Okay, so in terms of numbers, is there a number that you can pull out of both of those? 3. You can pull a 3 out. Do you all agree? Let's do that. Let's write 3. 3 goes into 3, of course. 3 goes into 75. Okay, how about letters? X squared, right? Because they both have two x's, two factors of x, so I can write x squared. Okay, real important here, and let's see. I don't remember who I called on last time, but I think we'll go off of this one. Christian, did I call you last time? It's been a while. I don't think you did. I don't think I did. I think this is my called on pile. So you're up, Christian. What's still in this parentheses if we pull out a 3x squared?
So that would be negative x squared
Negative x squared
plus 25.
plus 25. Yes. Everyone agree? Is that good? Okay, now, inside that parentheses, we need to count the terms. How many terms do we see in there? There's 2 terms, right? So if it's 2 terms, the only hope we have in this class of factoring is if this is a difference of squares. So is this something squared minus something squared? No, right? That's not a minus, that's a plus. Now, there's a couple of options here. I could flip these over and make it 25 minus x squared, or I could pull a negative 3 out instead of a positive 3. So which would y'all prefer I do? Flip these over, make it 25 minus x squared, or change the problem and go back and pull a negative out also? You want to do negative? I think that seems to be what most people would do. So let's kind of like restart, okay? This wasn't wrong. Christian, you did exactly what I think most people would do here. But recognizing now that this is kind of a difference of squares, if we pull a negative 3x squared out instead, then now that negative is accounted for, so in here I'm going to have positive x squared, and this is going to become minus 25 instead of plus 25, right? Is that all right? And then now we recognize this as being something squared minus 25 is a perfect square, so that's 5 squared, yes? So what's my next line going to be, Alex? Is Alex here? No Alex? Andrea? Okay, so what's this going to be here then? So we're using, well, I took the formula out of here. If we have x squared minus a squared, this will always be x plus a times x minus a, right? So we have something squared minus, now you have to recognize this is something squared, right? So what is the thing that's being squared here, I guess is what I should ask. Okay, so 25 is what number squared? 5, right? So you're really looking at x squared minus 5 squared, aren't you? So a is the 5. So now just plug into this formula. So it'll be what? Not squared. X, and then plus 5, and then x minus 5, and we're done. Okay? Now it's completely factored. All right, let's try this one. I have to think a little bit about this one. Hold on. 3x. Yeah, you know what, hold on. Let me think about this. Let me give you one like this first. See what you do with this. I'm going to let you start working that a little bit, see if you can get that on your own first, and then I'll call on someone. Okay, Becca? I just want to know, Becca, what the first step is for you here. Okay, did you pull out a GCF?
Yes.
Would you? 4x. What did you have left in the parentheses? X squared minus 16. Everyone good up to that point? Okay. And Becca, you see something in the parentheses? Two terms, right?
Yes.
Okay, do you recognize that as a difference of squares? Yes? Okay, so were you that far yet? Okay, what do you got?
X plus 4 next to this one.
Okay. Right? So if you kind of know what you're doing on these problems, they should go pretty quick. It's much faster than the grouping that we learned last class, and it's much faster than the AC method. But it just has to look like this for us to do that, all right? Let's do another one. On this one, what about Heidi? Heidi? Okay. First step. Okay, do you see a GCF? Something common to both. Mm-hmm. How many x's? How many factors of x can you pull out of there? Two, right? So you'll have two factors of x squared. Okay, Heidi, what would be left there if you take the x squared out of here? You'd be left with what? 9. Okay, minus, and then if you took two factors of x out of this, you'd x squared. Okay. Okay, now this one's a little different, only because, you know, in the formula, it's x squared minus a number squared, right? What we have here is a number, this is a number squared, right? That's 3 squared minus x squared. But the formula doesn't really even care if these are numbers or letters, okay? So it's just saying if you have anything squared minus anything squared, this is what it turns into. So Heidi, what do you think this is going to turn into then? What two factors? So what do we say this squared was? 3, right? Uh-huh. 3 plus x? 3 minus x. We're there. That's it. Okay, so that's the same sort of technique. It's just that the number and the letters were switched, right? Just follow the same process. Okay, let's do this one. I like this one. Zeke? All right, Zeke. First step, GCF. Do you have something common in both? No. Okay, so we count the terms. We've got 2, right? So it means it has to be a difference of squares, right? If it's going to be anything, it's got to be a difference of squares. So do you see something squared minus something squared? Okay? All right, so let's start with this one first. Now, I haven't been writing this, but I think for this problem I will. Do we all agree that 1 here is 1 squared? Like if that had been 9, I could write that 3 squared. Yes? Zeke, can you tell me what is squared here that would give you back 81x to the 4th? So what about the number? What number do I square to get 81? 9, okay. Everyone agree? Okay, now, what would I square to get x to the 4th? This one's a little tricky. What do you think? X squared. Yes, exactly. Everyone agree with that? If I square x squared, so like if you square the 9, you get 81. If you square x squared, you get x to the 4th. Do you all agree with that? X squared times itself would give you x to the 4th. Okay? So now, do we have something squared minus something squared? We do, don't we? Okay, do you want to keep going? Okay, so if we have something squared minus something squared, according to the formula, something squared minus something squared should turn into this. So I'm going to let you tell me, what does that turn into?
9x squared
Mm-hmm.
minus 1.
9x squared, you said minus 1?
Yeah.
Okay, and then 9x,
9x squared plus 1.
good. What do y'all think? Yes, that works. Good. Now you can always check. You can multiply, like you could FOIL this out. You could like multiply here, 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 and it should get you back there. It would, all right? Are we done? We're not done. Okay, so this is the first time this has happened. And all these other problems, when we got to here and here and here, there was nothing else we could do. Like here, like look at this right here. That's two terms, isn't it? It's a difference, but these aren't squares, are they? Like, so this is not a difference of squares. Over here, what we've got, this right here is a difference of squares again. Do y'all agree with that? Difference, 1 is 1 squared, and 9x squared is actually what squared? How do you get 9? So I'm gonna rewrite this. Let me see here. This right here is something squared minus 1 squared. And then the other one, why am I not looking at this one? Why am I not looking at 9x squared plus 1 and trying to break that down or do anything? Why am I not doing that? It's not a difference. We only have a formula when there's a minus sign. If there's a plus sign in between there, this formula is no good, all right? It is impossible to factor a sum of squares. You can only do a difference. So that's why I'm ignoring this. All right, so let's see who was up here. Victoria? There you are, Victoria. Do you understand what I'm saying here, Victoria, about how this can go further? Okay, so we said 1 was 1 squared, right? What is going to go in here? So what squared gives you this? 3x. Y'all buy that? You square the 3, we get 9. We square the x, we get x squared. So now again, Victoria, we've got something squared minus something squared. So this right here is going to use the formula, right? So what does it turn into?
Just, I guess, 1 for 1x plus 1, and then
Where are you getting the 1x from?
it's just x, right?
What is the thing that's being squared here? You told me it was 3x, right? 3x is the thing that's being squared, and then minus 1 squared, right? So in our formula, the thing that's being squared is this, the x, right? Okay, so that's our first piece here needs to be the thing that's being squared, which you told me was 3x, right?
Yeah.
So, understand?
Well, I guess
No?
so.
Well, tell me what you think the next line is.
I just thought, I'm just bringing it down to, yes, the next
Okay.
one, and then I just put, I guess, x.
Okay, I'm going to put what you think it is. X and then,
Well, so plus 1 and then minus 1.
okay, and then x minus 1?
Uh-huh.
Okay, so let's see.
3.
Okay, what now?
We still need the 3.
Yeah, see, because what is this thing supposed to multiply to come back to? It's supposed to come back to this, right? So on your first multiplication here, x times x, you're going to get x squared. You're not going to get 9x squared. You need it to be 9x squared, right?
Yeah, so then just 3.
3 in front of both of these, right? 3 here and 3 here. Now you'll get your 9x squared. The middle terms will cancel because we know that's what always happens. And then the last term will always be these two multiplied, which gives you this. I only did this to kind of help everyone see we've got something squared minus something squared. So this is like your x and that's like your a in the formula. Now we're not done. We still have a little bit more to throw onto the edge of that, right? 9x squared plus 1. This problem here is probably one of the most common ones that I put on a test, and people get it right and then they stop right here. They don't take it the rest of the way, so they don't get full credit. Always pay attention. Make sure that nothing in here is a difference of squares, all right? I'm going to give you another example of something like that right now. Everybody signed in here? Okay. So let's do this one. 2x to the fourth plus 10x cubed minus 4x squared. Oh no, make that 8x squared. I messed up. 8x squared and then minus 40x. All right, so this is kind of like the culmination of everything we've done. This problem is a very nice problem. Now let's see who the lucky one is. It's you. What's the first step? GCF. Okay, so do you see something that they all have in common? 2x. Everyone agree? 2x. All right, so we'll say this equals 2x. Now in parentheses, what's in here? X cubed, okay. Plus 5x squared minus 4x. 20. Perfect. Everyone got that? Got a common factor of 2 in every term, pulled that out. Common factor of x in every term, pulled that out. All right, we're moving on to the next person. Stephanie? Stephanie? Okay, Stephanie. What's that look for? Okay, don't be scared. Just marker on a board. That's all it is. Okay? Okay, how many terms do we have in here now? I shouldn't have asked you that because I was going to ask you what the next step is. Okay, but after we've done GCF, you then look at I erased them on purpose because I wanted to see, your next step would be to count your terms. So how many terms do you see inside this parentheses, Stephanie? How many do we have in here? 4, right? So what do we do when we see 4 terms? Oh, you weren't here last time? Oh, well, that's, sorry. No, then we should probably move on then. But pay attention because if you missed, I did post the lecture from last class. It should be posted, so I would recommend you watch it. Josh?
Yes.
There you are. Okay. Josh, 4 terms. Group them, right? So when we did the grouping in class last time, where did I draw that little slash mark? Where would we draw it here? Okay, between here and here, right? So like right here, or do I go in front of the minus or behind the minus? What did I tell y'all? Right before that sign, right after the second term, you slash it, all right? And now, remind me, what do I do next? I forget. These long weekends, I forget what to do. Do a GCF on these two, right? So what can we pull out of both of these? X squared, yes, everyone? Okay, x squared comes out. What would be left in that parentheses there if you pull x squared out of these two? What's that? X, you have an x, right? Okay, x plus 5. Okay, good. We're going to stop there, move on to the next victim. Vince? Okay, Vince, so we've got this first part done. I told y'all in class last time that kind of a shortcut way of doing this is to put what over here? Yeah, copy this, right? Just copy it over here, x plus 5, and then you try and come up with what now? The negative 4 that would get you back up to this. So we're trying to come up with a number right here that when we distribute it through, we get back this. So you said negative 4? I'm missing one thing. Everything I've written up there is correct, but I'm missing one thing for this to be completely correct. I need to close a parenthesis. So this parenthesis closes off this parenthesis because we still had that 2x in front. Okay, so events, these match, right? That's what we wanted. So my next line, Damien? No? Kayleen? See, you got your parking spot today? Good. Okay, what's the next line, Kayleen?
It will be parentheses x plus 5.
X plus 5? Okay.
Oh,
You want me to put another one here? Okay. All right, and
and
then,
then another parentheses x squared minus 4.
close it.
Equals
Close it again. Okay. What do y'all think of that? Is that okay? So from this line to this line is just what happens when you do grouping, right? So are the parentheses okay the way that Kayleen suggested? Is this right? It is, right? There's nothing wrong with this. There's nothing wrong. We had to have the parentheses here. This we had to have because the 2x is out in front of all this, and we've got things being added or subtracted in here. On this line, technically speaking, you actually don't need this. Now, it's not wrong, okay? But you don't need this one, and you don't need this one. The reason is because we have multiply, and so you don't have to have them, okay? It's, like I said, it's not wrong to have them. It's not wrong to not have them. All right. Kayleen, are we done? Can I box it up and move on to the next question?
no, the x squared.
Ah, good. Does everyone see that? What's that? It's a difference of squares. Okay? So like, you see why I said this problem is like, kind of got it all in here? You got a GCF, you've got a group, and at the very end we're going to have a difference of squares. So, continuing. Kayleen, do you want to just finish it since you've taken it this far? Are you comfortable with what this becomes?
Yeah, you'll add x plus 2 and x minus 2.
There you go. Now we're done. This becomes these two. Good. I like that problem. That's a good test problem. Yes? Y'all like that as a test problem? That would be fun? Or should I just do like this on the test? Just x squared minus 4, like that, right? That's what you prefer. All right. So in theory now we have a method for factoring, right? You should be able to handle pretty much everything in your homework in terms of factoring. We're going to move on. We have about 30 minutes. I want to start to get the next concept going here. So our next goal now that we have factoring in order is to be able to solve, I'm going to put next goal because it's not our ultimate goal, but it's the next one. Solve quadratic equations. In other words, we have this. Somebody gives us an equation that looks like this form right here. So that's the general form, but let me give you a specific example of this. That's an example of a quadratic equation. Our goal is to be able to solve this, all right? Now, I talked last class about the fact that when you look at quadratics versus linears, that linear equations draw you lines, but quadratics draw you these parabola things. And solving them, setting them equal to 0 will be the same thing as trying to find x-intercepts. So that's the long-term goal. But right now we want to know, do we have a way of solving something like this? So to do this, to move into this next concept, we need to first establish what's called the zero factor property. And I actually showed you this already, but now we're going to formally talk about it. The zero factor property says that if any two things ever multiply to be 0, then one of them has to be 0. This is a property of our number system that you cannot change this. This is the way it is. So what it's saying is this. Let's say I have something like 4 times x, and I tell you that that's equal to 0. Do I have two things being multiplied? Okay, are they equal to 0? Okay, two things being multiplied equals 0 means that either the first one is 0 or the second one is 0. Well, 4 can't be 0, right? 4 is 4. That means that this one has to be 0. So our solution here is what? X is 0, right? That's the only way this will be true, is if x is 0. The mistake that people make with this, and I don't want to erase that. The mistake people make with this is they'll think that this property works for anything. So like if I say two numbers multiply to be 1, does that mean that one of them has to be 1? Does that mean A has to be 1 or B has to be 1? No? Can you give me an example of two things that multiply to be 1 where neither one of them is 1?
0.5 times 2.
What's that?
0.5 times
0.5 times 2. I'm going to do it this way. 1/2, 0.5, times 2. Does that equal 1? Half of 2 is 1, right? That's not 1. That's not 1, right? So when we have a 1 here, this doesn't work. When we have a 0 here, it does. Okay, that's why they call it the 0 factor property, is that when this side of the equation is 0, as long as these two things multiply to be 0, then one of them has to be 0. Now, why is that useful? We'll come over here to this. Okay, so that was not a property, right? Come over here to this. Right now, I want to know when this is 0, right? Well, this right here, we can factor, right? The left-hand side. That's, we would do GCF here. There wouldn't be a GCF. We'd count the terms 1, 2, 3. And then we'd say, okay, 1, 2, 3, that's AC method, right? So then we go through our AC method. I'm not going to show that work, but I hope that everyone could get to this point right here. Anyone know what it will be?
-3 and -2.
-3,
Or +2.
+2. Okay? So I'm putting ... meaning to go from here to here, that's last class, that would be AC method, all right? We'll get more practice with it, but just for the sake of me trying to explain what we're doing. We're trying to solve this equation. We want to know when it's equal to 0. All we have is the 0 factor property, which says if two things multiply to be 0, then one of them has to be 0. Well, these two things are being multiplied to be 0, right? So that means either this is 0 or this is 0. One of the two, right? So my next step is to say either x minus 3 equals 0, right? Or I'm going to put a line between these. X plus 2 equals 0. Okay, so I just have to figure out what makes this true and what makes this true. And do y'all recognize these are just linear equations? You can just isolate x, just solve for x, right? Add 3 to both sides here, subtract 2 from both sides here, and we get two solutions, 3 and -2. Right? But the key to the problem, there's actually two keys to the, well, there's more than, there's like 3 things that you have to know. You have to first know you're looking at a quadratic equation. Then you have to realize you can use a 0 factor property. And then you have to be able to factor, right? If you can do all that, then we can solve these equations, these quadratics. Let's try another one. Okay, so Christine Gonzalez. No? Christine? How about Evan? Did I call you already? No?
Last time.
Last time? Yeah, I think we've restarted here. Evan, what type of equation is this? Is it linear or quadratic? Quadratic, because of what makes this quadratic and not linear? Okay, so is it the fact that we have x's that appear in two places, or is it the power on the x that makes it quadratic? It's the x squared. Okay, so everyone, when we look at this, we all have to recognize that is a quadratic equation, and it's because of the squared on the x. Because it's a quadratic equation, the way we solve it is completely different than the way we do linear. The way we solve these is to first do what? So Evan, I want to use the zero factor property, right? Which means I need a 0 on one side. So I'd like to get a 0 on one side of this equation. What do you suggest I do to do that? Like let's say I wanted to put a 0 over here. I need to take away the 6, right? So if I take away 6 here, I have to do it here and to the other side, right? So if I subtract 6 on both sides, 6 away from 6 is going to give a 0, and then when you take 6 away there, I'm here. Okay. Now, once we're here, we're going to try and use the zero factor property, which means we have to somehow break that left side down. So now we go through our procedures. Is there a GCF? No. How many terms? 3, so we're going to use the AC method. Okay. Now, would you all like me to go through it or just show the factored? Just show the factor. I'm going to just show it on this one. The factored form of this one. Uh-oh. What is it? +6 and -1. So are you guess and check pretty much? Okay. So that everyone needs to understand this step to this step, you must be okay with this step. Like maybe not mentally, like just do it in your head, but you've got to be able to do it on paper. And we did that last class and you were supposed to do that for your homework. So make sure you can do that or else you won't be able to do these problems, right? Okay, now once we've got two factors, right, that multiply to be 0, what do? Set them each equal to 0, right? Each one of them set equal to 0. So we go x plus 6 equals 0, and then x minus 1 equals 0. And then we solve these. These are just linear equations, so you just isolate x. So subtract 6 from both sides here, add 1 to both sides here, and you have your two answers. Now remember, what these answers say is that if you replace x with -6 in here, this should be true. So if I put -6 right here, what would -6 squared be? 36 plus, what's 5 times -6? -30? What's 36 plus -30? 6, so that's true. It works, right? And it'll work for 1 also. Okay. Now we're going to do some more work with this, all right? But I want to give you a very special problem. So how about this one? How about x squared, let me see here, minus 9x plus 3, equals 0. Sylvia. What type of equation is this, Sylvia? Linear or quadratic? Quadratic because of the squared, right? Okay. The reason I keep asking this question is because on your next test, you might have to solve some linear equations, which is a certain method, and then on other problems, you might have to solve quadratic. So you need to know what to do by looking at it first, right? Quadratic equation, and so what we want to do is get this thing equal to 0, which it already is, right? So now we look at the left side, count the terms. We have 3 terms. AC method or guess and check. So can anybody guess and check this one? Can anyone just see what it is? No. So let's try the AC method, because the AC method was our other fallback. How did that go again? I drew something like this, right? Sylvia, do you remember what I did here?
Yeah, so A times C goes up the top.
Okay, so what's A times C? Yeah, it's this 1 times the 3, so that gives you 3. That goes on top, and what goes on the bottom? Minus 9, and then I'm supposed to, or we're supposed to come up with numbers that multiply to be this, but add up to be this, right? So they have to multiply to be 3, so I could only have like 1 and 3. I could also have -1 and -3. Are there any other numbers that multiply to be 3? And that's it, right? That you can come up with? These need to add up to be -9. Not happening, Sylvia, right? So what would we normally say at this point? It's prime. That's what we'd say, right? This is prime? And that would have been the correct answer on your homework from last time. But here's the difference. In your homework last time, you were looking at that, right? And being asked to factor. Now we're being asked to solve, and that changes the game completely. This actually does have 2 solutions. The problem is our method of factoring isn't powerful enough to actually get the answers. Because when we say this right here, come up with 2 numbers that multiply to be 3 and add up to be -9, all you're thinking of mentally are nice numbers, right? Integers, right? But let me give you an example of 2 numbers that multiply to be 3. How about this? 1/2 and 6. Do those multiply to be 3? Right? Now they don't add up to be -9, but I could keep doing this. I could do like 1/3 and 9, right? Those multiply to be 3? They don't add up to be -9 though. What I'm getting at is you can do this with pretty much any fraction. 4/5 4/5 and then 15/4. Do you all agree that those 2 numbers multiply to be 3? Let's see. What would I get across the top? 4 times 15 is 60. 5 times 4 is 20. 60 divided by 20, that's 3. These multiply to be 3. Maybe they add up to be -9. What I'm getting at is your list, we've been stuck in nice numbers, right? But if you can actually think of like fractions too, then that changes the game, doesn't it? And look, we're never going to be able to do this with fractions. Okay, we're always going to just look at these nice numbers. So that begs the question, how do we solve this? If there are 2 solutions, how do we solve it, right? Yes? Okay. Does anybody know what we're going to use? The quadratic formula? What the heck is that? Some formula? Some magic formula, right? So we're stuck, yes? We're stuck, and I've got about 10, 15 minutes. Let me see if I can show you this. So I don't necessarily need you to write this down. This is not going to be something you're tested over, but that also doesn't mean pick up your phone and start texting your friends. This problem right here of solving a quadratic